Hello, welcome back. Let's talk about profit maximization in pure competition or perfect competition. And we're going to use the graphical approach. So let's take a look at the graphs for a typical firm that operates in pure competition. As we know, a firm in pure competition has a horizontal demand curve. This demand curve is also its average revenue curve, which also equals its marginal revenue. In this graph, this perfectly competitive firm is selling its product for $8. The red curve is the firm's marginal cost curve, as we saw in the last unit, Unit 5. The yellow curve is the firm's average variable cost curve, and the blue curve is the firm's average total cost curve. So at which quantity produced, 1 through 13 that's given here, does this particular firm maximize its profits or perhaps minimize its losses? Sometimes a firm has a loss at any quantity and is trying to minimize it. In this case, we can see that the average total cost curve, the blue curve, is below the average revenue curve, so that we will have a profit. So we're going to try to maximize profits. Well, let's start at a relatively low quantity. Let's take a look at quantity 4. And we'll see that the marginal cost is relatively low there. And so is this the quantity that we're going to be producing at? Well, if you look at the average total cost at this quantity, it's pretty high, and in fact it's above the average revenue curve, so we're going to operate at a loss. So this is not a really good quantity. And also because higher quantities will give us a profit. The other way that you can look at it is if we went from 4 to 5, you can see that the marginal cost is around 1. So if you draw a line over to the vertical axis, the marginal cost is around 1. So every time you sell an additional product, let's say we sell our 5th product, it's costing us $1. That's what marginal means. The additional cost is $1. Well, the price that we get for our product, the demand curve, is at $8. So selling that 5th product will get us additional profit from where we were at quantity 4. And we can say the same thing at quantity 6. Now the marginal cost is a little higher there. It's almost $2 here. But still, it's costing us an additional $2 to make our 6th product. And we're getting $8, so we're adding to our profit. Essentially, we're going to keep doing this until our marginal cost reaches the marginal revenue or the price of the product. So at 7, quantity 7, looks like our marginal cost is 3. So it's costing us an additional $3 to make it, and we're selling it for 8, so we are adding to our profit. We can do the same thing at 8, quantity 8, and so forth. And it looks like finally around 10. That's where we have a marginal cost of 8. And we also have, so it's costing us $8 to make that 10th product. And we're selling it for $8. So that's actually kind of a break-even point in terms of whether you want to make 10. But we're going to say that that's where we stop. So we're going to make 10 products. That's where we have our maximum profit. We're certainly not going to make 11 products because if you draw that yellow line up to the marginal cost curve, our marginal cost there looks like around $10 or $11. So our 11th product, 11th quantity, it would cost us about $10 or $11, and we're selling a product for 8, so we would lose profit at that point. So 10. This point here is where the marginal cost is equal to the marginal revenue, and that's where we have our maximum profit. By the way, we always are going to have maximum profit where MC is MR, except if you look at this point, MC is also MR, but that is actually the worst point, so that's your maximum loss. So now that we've determined what the profit maximizing quantity is, 10 in this case, let's take a look at what the actual profit is for this company at the profit maximizing quantity. Total profit equals total revenue minus total cost for this firm. However, we don't have total revenue in this graph and we don't have total cost in this graph. But we do have average revenue and we have average total cost. So we have the averages of those revenues and costs. So the average revenue is at 8. And so that is here. And the average total cost is right there. So if we take this difference, the average revenue, $8, minus the average total cost, and that looks like, if we go to the vertical axis, a little bit above 4, let's say 425. So we know that the average profit for the firm is 8 minus 425, so about 375. That's our average profit. And if we multiply it by the quantity, of course we know that this quantity is 10. And we know that 10 times 375, or 3750, which also is the same as the area of this rectangle, length times width, equals 3750. So this firm is experiencing an economic profit, a positive economic profit of 3750. Of course, this firm is in a purely competitive industry. So to have an economic profit, which means an above normal profit, because the costs include implicit and explicit costs, any profit, any economic profit that's positive for a firm is an above average or an above normal profit. And of course, that's in the long run, that's going to disappear, and we'll show that in a few seconds. It's also possible for any firm to incur a loss. So let's take a look at that situation right now. Here we have a situation where the price of the product is considerably lower. It looks like it's around $3 here. The green line gives us the price line or the demand curve. So if we do the profit maximizing rule where MC is MR, let's take a look to see where MC is MR. Well, MR is the green curve and MC is the red curve. So it'll be around this point here. If we did maximize profits, we would look at that quantity. It's around 8. And so our profit maximizing quantity is at 8. But we also see that the average total cost at that quantity is higher. It's around 4. So we'd be losing money. Now the question is, should we shut down? Should we not operate? Is it better to not produce at all? Or should we produce 8 and incur this loss? So in order to determine that, we have to consider a couple things. First of all, we have to realize that we're working in a short run, and we do have certain fixed costs. So if we shut down, we still have a loss. Now, is that loss greater than if we did operate and produce 8 products? How do we know that? Well, we got to look at the average variable cost in that particular case. So if we look at the average variable cost, we notice that average variable cost at quantity 8 is here, and that's around $2. So we are covering our average variable cost because we're charging $3 for the product. So if we only had variable costs, we would actually make a profit. So that means that we're actually covering part of our fixed costs. And so here in this case, it means that if we did shut down, we would have all of our fixed costs, and we would lose that much money. Let's say, I'll make up a number, let's say we would lose $40 or so. But if we produce here, we would be profiting based on our average variable costs. So we'd have a loss that's less than our total fixed costs, so maybe $20. So in this particular case, because the price is above the average variable cost, we do actually want to produce at the quantity 8. And we would actually be minimizing our loss. Now, if the price had been even lower, so let's say if the price was around $2 or a little bit less than $2, we have a different situation here. So now we see that the price is actually below the average variable cost curve. If we used our profit maximizing rule, we would produce this quantity here. We definitely have a loss because average total cost is here. Now we notice that average variable cost is also above the price. And so we would actually be losing money on our variable costs. So not only would we lose our fixed costs, but we would be losing money on our variable costs. So here, at this quantity, it's clear that our total loss at quantity 7 is actually greater than if we shut down. So we can say that if the demand curve or the price is below the average variable cost, then the company would actually be better off shutting down or not producing anything, at least in the short run. And in the long run, it would just hope that either the price would increase because of better market conditions, maybe the economy would strengthen, or the firm would just have to lower its costs so that at least the average variable cost curve would be below the price, or in the long run, preferably the average total cost curve would be below the price so that the firm would be making a profit.